Solving proportions. So example 1. So we have 3 over 4, which is equal to x over 8. And so the whole point is we need to solve for what x is. So for us to do this, let's go ahead and just rewrite it right here. So now how we can solve is we can do this trick, and so it's called the butterfly. We can do this trick, and what we do is we're going to go ahead and multiply across this equal sign. And so how we do it is in this butterfly fashion. So we would go 3 times 8, and we'd go 4 times x. So we have 3 times 8 and 4 times x. Now, we could have done this multiple ways, and we can show some other ways on the next example. But let's go ahead and keep this going. So we have 3 times 8, so that's 24, which is equal to 4 times x. Then we just need to go ahead and get x by itself, and so we go ahead and divide by 4 on both sides. This just becomes 1, and 24 divided by 4, which is 6. So x is equal to 6. Now, if we have that, so we have 3/4, which is equal to 6 over 8. So let's just kind of explore proportions here, since we solved for x. Now, if we were to think about this, right, if we were to draw say 2 boxes, and let's just say these were the exact same shape. I know they're not, but just imagine that they're exactly the same. Well, on this side, we're going to go ahead and divide it into 4 boxes. And then on the other one, we're going to do 8. So 1, 2, 3, 4, 5, 6, 7, 8, and then 4 on the other one. Then let's go ahead and color in 3 of the 4 boxes on the first one. And then let's do 6 on the other one. Oops, that went too far. So we can notice that this might be 3/4 and this might be 6/8, but it covers the same amount of area of this larger box that they're all in, right? This one's just divided into 8 and 6 are colored in. This one's divided into 4, 3 are colored. And then another way to think about it is like by graphing, right? So this might be something you haven't really touched upon as much, but if you were to have a graph, so 3 out of 4, and then we have 6 out of 8, right? It would, right? And if you just keep going, right? This 3 out of 4, right? It creates this slope. And so both of these, right, if with the origin, would have the same slope. So, right, if you were to draw this point, it would keep going and hit this other point. And this point with the origin, right, they create the same slope, which is a really important kind of concept. And so that's how that's related, graphing with proportions. And another way we can look at it is through even, say, triangles. So if we were to redraw, right, this triangles, what we notice that 3 out of 4 and 6 out of 8, that this one's just twice as large. And we can just see how they have the same proportions of the sides, right? Like 3 to 4, 6 to 8, right? It's just twice as large. So this one's 3 times 2, and this is 4 times 2. So that's 8. So this is kind of showing just different ways to kind of make connections in math and how it works out. Now, let's go ahead and solve the next example. So, example 2. A pour-over coffee machine says you need 12 grams of coffee for every 200 grams of water. How much coffee do you need if you want to have 350 grams of water? So this is a proportion problem. So this is kind of a fun way to solve. I do this a lot when I do my coffee in the morning with my Chemex. And so how we can do it is we can set it up as 12 over 200 is equal to x over 350. Now we can go ahead and solve the way we did with the butterfly, or we could do it a different method. And how we get right denominators out is we go ahead and multiply it on the top. And that way, right, this just becomes equal to 1. But whatever we do to one side, we have to do to the other. And so what are we left with? So we're left with 12 times 1, so that's just 12, which is equal to 200 times x over 350. Now let's get rid of the 350. So we go ahead and multiply both sides by 350. We get rid of it on that side. And so what are we left with? We're going to go 350 times 12, which is equal to 200 times x. And then to get x by itself, we would just go ahead and divide by 200 on both sides. So we get x, which is equal to 350 times 12, divided by 200. So let's get our calculators out. So we get 350 times 12 divided by 200, and we get 21. So x is equal to 21, right? All of this is equal to 21. And so when we go back, that's how many grams of coffee we need for 350 grams of water. So that just means that we want to have the same strength of coffee, right? For 12 grams of coffee, right, of coffee beans, we use 200 grams of water. And so we would use 21 grams of coffee beans to use 350 grams of water to equal the same strength. And that's how proportions work. Now let's go back real quick to show you how the butterfly also works for this, right? Rather than multiplying both sides, right, by the denominator, we could have done it like this, where we go back and we go ahead and use the butterfly. So that is equal to 12 times 350. And then we have 200 times x. And look at that. We get this, right? We get the 350 times 12, which is equal to 200 times x, right? And then we would have just divided by 200. And we get x is equal to 21. So that's how we could have also got this. So we could do it this method, or we can go ahead and do this method by the butterfly.